All right. So it is Tuesday, April 4th, and it is 7 o'clock Eastern time, 4 o'clock out here in the Pacific Northwest. And we are jumping into week number 9. Hard to believe we're already in week number 9. And I'll talk about how many sessions, how many synchronous sessions we have left with respect to Zoom. But before we do that, let's go ahead and catch up and see where we're at. So we had in the syllabus, we had 2 activities that were due this week. Hopefully you guys enjoyed these activities, and they were both really, really good activities. And that was 627, build a sample web app in a Docker container. And we're going to take a look at that. We're going to get another sort of bite at the apple here tonight. You're going to see me put that together, and then you're going to see me actually push this to GitHub. And then I'm going to actually use a Jenkins installation I have in my AWS cloud setup. I've got some servers out there that I use for teaching and personal stuff. And we're going to go through that. And so you're going to see what a sort of, CI/CD pipeline, the continuous integration, continuous delivery or development. And we'll talk about the semantics there in just a second. And then you had the password methods in Python. So these were the 2 activities that were due this week. So now we shift ahead to what's going to be coming due and what you guys are going to be working on this week. So you've got a discussion post, right? Module 6 discussion, cloud development models, containers, and security. You've got this project activity here, which I'm going to talk about in detail in just a second. And then you've got the module 6 exams. So on the chapter module exams, all of the chapter module exams are active right now. So what that means is with your 10 attempts, you can take the module 6 chapter exam. You could take the module 7 chapter exam. You could take the module 8 chapter exam. And that should give you a pretty good time frame with which to work on those chapter module exams, because again, they're all open right now, and then they close out, like for example, not this week but next week we're going to be doing chapter 7, and you can see the chapter 7 module exam is there, but then the chapter 8 module exam is way down here. It's not due till March or May 8th. And so that also brings into question how many synchronous meetings do we have left? In other words, how many of these Zoom sessions do we have left? Well, we've got this week, and after tonight, there are only 6 more synchronous sessions left. That's it. So keep that in mind also. So let's dig in here a little bit and talk about this 637 project activity 4, automated software testing and deployment. And you can see right here, here's the rubric for this activity. And this is what would get turned in, and only your Scrum leader needs to turn this in. Yeah, only the recorder needs to submit. So this is what's going to get turned in. And here are the questions that it's asking. Which features did your team choose to implement from your backlog, right? So if you had features you were going to implement that were in your backlog, you would list those out here. What were the specific objectives of these features? Why were these features chosen? So maybe you decided you wanted to add in some other feature into your program. So you're going to highlight that here. You're going to provide a brief description of your team's strategy for completing your project. And here are going to be the deliverables, right? So there's going to be a presentation, and this is what you're going to provide, right? The following evidence that you actually did what you were supposed to do with something that was a backlog feature that you guys thought, well, let's try to do this, or maybe we won't. But then you decide to do that. So it's going to be information about your app, covering the features your team included, the reasons that your team decided on those specific features in your application, the code with the new features that are implemented, and that's what they refer to as the backlog, right? You're going to show your changes pushed to GitHub. Now, technically, I'm not going to be too concerned about that right there. You could just give me a screenshot literally of like, if this is my GitHub repo here. This is the repo we're going to be looking at tonight, which is the AACC sample app. So really all you'd have to do is show a screenshot of your GitHub repo that, hey, look, I was able to push my changes up into GitHub, and that'll be good enough. That'll be good enough. You're going to provide test cases used. So if it was just, oh, I started the application up and I ran the application and we had all the team members ran it and everything worked great. Okay, that's going to be good enough there. Describe the CI/CD pipeline functionality. And so that's what we're going to kind of talk about tonight, because that comes up this evening. So you'll have a better idea of what we're talking about in terms of, you made your changes, you committed your changes to your local Git repository, and then you push those changes up to the main GitHub repository, and then other users in your group could pull down the changes and then run the application. Right. So that's an example of the CI/CD pipeline. You're not going to be expected, and it's interesting. And I was going to check with Mary on this. It's interesting that the activity that is the Jenkins lab, and the Jenkins lab it's a really good lab, but that activity is not here. Like, you guys are not assigned that Jenkins activity. And I understand why, because it is a little bit more complex, but it's actually a pretty good activity to walk through. And I'm actually going to walk you guys through it tonight, because that is, when we talk about CI/CD, that's really what we're talking about. Is Jenkins is one of the possible tools that you could use for CI/CD pipeline stuff, right? For the continuous integration. And it allows you to create it. And literally, you'll see that there's an option in there that literally says pipeline, right? It says pipeline that you can choose in Jenkins, right? And so I'm going to give you a great example of building and then making modifications to that same sample web app. So again, in the course, if you were looking for that lab, it's 636. But again, you'll notice it's not here. And again, I get it. I know why it's not here, because it is a little bit more complicated. And you've got this activity 637. I think that the Jenkins activity, though, gives you a good idea as to the things that you can do in terms of automating some stuff, or making it like single click in order to test, hey, is my app actually working, right? So we got 6 meetings left, and then you've got a demonstration of the application. And so again, it doesn't say that you have to have 10 backlog items. If you have a single backlog item, that is going to meet the requirement. And so that's really what it's looking for, is for you guys. So Christy, to give you a good example, I think you had said that there was a piece of code that Dylan had worked on, I believe, and that you guys couldn't get it working all the way. Well, that would be a perfect example of a backlog item that you guys would go ahead and integrate into your application and get it working. And then that pretty much would complete part 1 of this activity. And then part 2 is just reflection questions, right? And so every team member, right? So everybody needs to do part 2. So part 1 is the Scrum leader. Part 2 is what everybody has to do, because that is each individual's sort of personal reflection on the activity, right? And so that's it. And the questions in the reflection are, these are kind of low-hanging fruit here. What did you enjoy about working as a team? What worked well? What problems did you encounter? What technical problems did you encounter? Like GitHub, right? Maybe you guys ran into an issue being able to push and pull from GitHub. That's a great answer to that technical problem question. And you can detail what happened there. So again, it's a really straightforward activity. And the only and again, you only have to have a minimum one backlog item to include here. That was it. Can you post a link to a video for the demo? Yeah, so you'll be presenting. Yeah, you'll be presenting. If you guys wanted to do a video, that would be very, very cool though, because you could even say, and it would probably be good practice as well in preparing for the presentation. But yeah, go ahead and do up a video. And again, not required, but would be great practice, and would certainly add value to your submission, is to just do up a video and then present what you show in that video. And I know when you look at it here in Canvas, and let me talk about this here for a second. So when you look at it here in Canvas, the information is there and it's good information, but I would highly recommend coming over here to 637 in the DevNet Associate course, and also taking a read through. Wait, should take us all the way down here. Hold on one second. There we go. Take a look at section 637 in the online course, because this is going to give you a really, really good breakdown, much more information than you see inside the document that's in Canvas. Now, some of the information is the same, right? Final deliverables, the presentation, team activities and reflection. So, but it gives you a really good idea of what you're looking at, right? So the marketing departments receive favorable reviews and feedback on your app. Manager required funding and the resources of your team to add some of the backlog features. And again, at a minimum, you guys need to have one backlog feature. So Christy, I already know what your group should be doing. We'll talk about the other group here shortly. And Nathan, were you in the other group? Were you in group?
Yes, I was.
Okay. So I'll come to you. We'll come back to you here, unless you want to do it right now. Are you prepared to talk to your group's project and to demo what you guys came up with?
Unfortunately, I'm on my phone right now, so
Aha.
I'm not gonna be able to demonstrate it tonight. I'm
So
not
that
gonna
is a
be.
no. Okay.
Yeah.
All right. So yeah, so we'll circle back then, because I'm not familiar with your group's presentation or your group's application, like what backlog items you might have had, what worked, what didn't work. So again, I would come in and take a look at 637, and it's not very heavy lifting at all, right? You got to do one backlog item, and then everybody has to do part two, the reflection questions. And I'll make sure that I cover that in the email that I'll send out here later this evening, because again, I'm 3 hours behind you guys. So by the time we're wrapped up here, it's only 6 o'clock out here. So I'll get everything posted up and make sure that the lecture link is in there for YouTube, so that you guys can come back and take a look at this if you need to for reference. But again, 637, and that is going to be what is due this week. Now, in addition to that, I want to make sure that I call your attention, and look, we're getting almost to the point where I can go all the way to the bottom here, right? So our last meetup is Tuesday, May 16th, right? That's the last time we will be meeting on Zoom. And so here's what's coming due this week. Let me call your attention to, and where did it go? This activity right here, 869. So in your groups, right, and this is due on May 15th. So as of right now, what is that? How many days till May 15th? So if it's 35 to the 9th of May, it would be 6 more days. So you got 41 days as a group, and you guys are going to be working on this here. And I would, again, I've called attention to this a couple times, but I want to make sure I highlight it again, that this is definitely going to be some heavy lifting for your team. So I would start tackling this sooner rather than later. And this is and this is one of the misleading things is, so here's kind of the document, and it talks about yeah, final deliverables, and here's what you need to deliver, right? And then that's kind of it in the Word document, which is why I highly recommend rolling over to Module 8 and taking a look at Project Activity 5, Network Programmability and Automation. And again, this is definitely going to be some heavy lifting here. And we start down this road next week in terms of some of the components you're going to need to be able to complete this. But the video, so there's already a video up that shows different scenarios for things that you might be able to do using Yang and NetConf. And I was actually using RESTConf. But here's the scenario, and you're going to want to read through this to make sure that you guys kind of have an understanding of what it is you're trying to tackle here. And it's very straightforward. You're simply going to be verifying a running config on a CSR 1000V. You're going to make 3 changes to the configuration, and those changes could be as simple as creating new loopback interfaces. That's all you would have to do there. And then you can verify those changes, show IP interface brief, and then display the new running config. And then you can send a notification out to the WebEx Teams group. And this is going to be a Teams group that we'll be creating. But again, I would definitely take a look at this and start thinking about how you're going to tackle this. And again, you could even look ahead at some of the videos that are out there already. And then there's team activities and reflection again for this. But we got 41 days, but this is definitely probably the heaviest lifting because these topics, Yang and NetConf, automating it with Python, and then tying in WebEx Teams to it is probably the most complicated thing you're going to be doing in the course without a question, right? But the good news is the videos with all of the component pieces that you would need to pull this off are already out there, right? So you would just need to dig in and go through the different chapters that are in here. All right, so any questions about what we've got coming due this week, what we're working on this week, or we've got 6 meetings left. The chapter module exams are all activated, so you can start taking those at your leisure. Remember, you get 10 attempts, 5 hours per attempt. So any logistical questions? All right. So I think we're good on the logistics. Okay. So if we are good on the logistics, let's talk about the CI/CD pipeline. So continuous integration, continuous deployment. What is it? Well, continuous integration is all about your code compilation. If you're doing any type of testing, maybe you're packaging things up and doing some versions on things. That's kind of the continuous integration, right? It's all your developers and they're continually merging all of their changes into your program. Now, remember, we use Git and we use GitHub. Keep in mind that there are a multitude of products that are out there that you can use, right? And I'll leave this sitting here on the Jenkins screen for now because this is going to play a big part in what we're going to look at tonight. So the CI/CD pipeline, at the end of the day, I don't know of any companies, and I've never worked in any companies where I've seen that every single individual component of a CI/CD pipeline is being used. Typically, what's going to happen is there's going to be some combination of tools that are being used, but it's not going to be like when you see it in the reading and they show you that little diagram that has like the developers, and actually let me pull the diagram up here, that has like the developers writing code. It like starts to talk about, where'd chapter 6 go here? All right, so here we go, continuous integration. So if we were to look at this diagram here, which should be popping up here any second now, there it is. So this diagram here, right, this is just kind of like, hey, in an ideal world, this is what it would look like. And again, I'm sure there's some companies out there that are doing this, but at the end of the day, it's going to be some subset of what you see here. And so what do we start with, right? We've got our developers that write the code, and then like we're doing, right? So like as you guys are doing in your teams. So you're together in your teams and everybody's working on their code. And theoretically, everyone is then committing their code, and maybe you're doing it locally, right? So with Git, and you're doing your commits, and then you're pushing up, right? Push. You do your push request, the Git push up to from the origin to the master. And then maybe you've got some process here that automatically builds the code. And so this piece right here could be Jenkins, right? Jenkins could be this little piece right here. Now, what I'm going to show you is a manual example of using Jenkins, but you can configure Jenkins so that when someone does a push to your GitHub repo with an update to the code, that Jenkins will automatically run because it's integrated with GitHub. It'll sense that, hey, Dwayne just did a push to GitHub, and Jenkins will run a test that you have defined, and it does it auto-magically, right? So then if there's no errors in the build of the code, you could have it run certain tests. And that lab that I referenced, 636 in Jenkins, has you create some freestyle projects, right? Or a freestyle project. And then it has you create a pipeline project where you've got the build of the code. It's not automatic. You manually build the code, but then you're running a test. And remember that sample web app that we created, remember what that said to us when we ran it on the local machine. It said, you are calling me from, I think it was 172.17.0.1 or something like that, when you did the Docker container, right? Because that's our application here. That's the application we're talking about. And so then it would run some automated tests. Now, if the tests fail, well, I should say here, if it doesn't build, if your code crashes and it doesn't build, well, then, hey, we go back to the developers, right? But maybe the code builds, but then we get to the testing, but then there's errors with the testing. Well, then it goes back to the developers, okay? Now, if there's no errors, the build ran like it was supposed, the build successfully built, and the automated test ran and there were no problems, then we come down to here. So again, the continuous integration is the writing of the code, the building of the code, the testing of the code. So if you remember that, especially if you're going to sit for this exam, remembering that continuous integration is, think of it as like we're integrating our code. We're building and testing the code. That is CI. So that's the CI portion of CI/CD. And then you've got like this little semantical difference here between continuous deployment here on the left, which means auto-magically deploy the application to production, which that would be a super, super mature, like I'm sure Amazon, Microsoft, Google, that's probably happening with organizations like that are super mature, right? But if you're not super mature like that, maybe you've got some human safeguards. And what this means here, right, is so we go from continuous integration down to continuous deployment or delivery. And the only difference is if we're deploying, there are no human safeguards. And what that means is after the automated tests run on your code, if those tests pass, boom, it gets automatically deployed into production, right? And that would be a mature organization. Now, obviously, the opposite of mature is immature, but I don't mean that in a negative, I don't want to have a negative connotation, because maybe your organization does have human safeguards, because maybe that's not such a bad thing. And I'll give you a great example of this. This is what I've spent the last 2 days doing almost nonstop. So this is a little segue here. So we'll take a break right here and do a little segue. So we'll talk about what happens when things get pushed to deployment and it looks like no one tested them. So I'll give you a great example. So we have FortiGate firewalls. Now the company name is Fortinet, and the firewall product they make is called FortiGate. So one of the features of that firewall is that you can permit or deny traffic based on location. So if I'm a government organization, what I could say is, we're not going to allow any inbound traffic from bad actors, right? I'll use North Korea as an example, right? So maybe the US government doesn't want to allow inbound traffic from North Korea to its web servers or to its, Department of Commerce servers or whatever the case may be. But you can do that and you can simply pick the country, right? And it will work. Well, there's a couple ways you could do it. You could do it based on location. So you could say if it's from North Korea, or you can say how the IPs are registered. So if they're registered by North Korea, then we're going to block those as well. So on Friday afternoon, last Friday at 5:15 in the afternoon, after everybody's gone home and no one's around, they pushed it's called IP geography database or geo IP database. They pushed an update. And in that update, if you were trying to do matching based on how the IP address was registered, they broke it because all the United States IPs came back with a country code of ZZ, which is a mistake. It should say US. And so a lot of unsuspecting customers, and I was one of them, found out on Saturday that all of our stuff was down and that the firewall was blocking all of the traffic. And so you had some developers. And so let me circle back and tie this in here to what we're talking about. So Fortinet had some developers writing their geolocation code. They built the code. I don't know what kind of tests they ran or if they didn't run. And then that got pushed out and it broke anybody with the FortiGate firewall. It broke their ability to successfully use geo matching for US registered IP addresses. Totally broke it. So that may be where a human safeguard might be of value. And so we basically had to figure out what the problem was. And we were one of the first people to call in to be like, hey, listen, something's not right. And then they figured it out. They replicated it. And now they're telling us it won't be until later this week that they'll have a fix. And literally all they need to do is change the 2 capital Z's to US. But they're saying it's going to take days to do that. So who knows? Maybe now they will have some human safeguards in there. But they did. I tell you what they didn't test, and that was for registered IPs that were US IPs, and that was broke, right? So that might be where a human safeguard comes in handy. So maybe you do have a human safeguard, right? So integration's all about the building, the testing, the writing of the code. Continuous deployment is if it's auto-magically pushed out into production. Now, if there's a human involved, that's what we call continuous delivery. Because here's where the human would say, well, hold on. Before we push this out to production, maybe it's a good idea that we put it into, and we talked about this last week, the development area or the staging area or the testing area before you push that out into production. And that might not be a bad idea, because maybe you've got some QA engineers who are running tests. And if these tests fail, this is kind of like Chutes and Ladders in a way. I don't know if you guys played Chutes and Ladders or if you have kids that played Chutes and Ladders, but it's kind of like Chutes and Ladders where we get here and it's like, whoops, failed QA engineers are running tests and it failed. All right, all the way back to the developers. So we ran tests and this failed. You need to look inside your code and figure out why it failed. And then we walk through the process again. But if there's no errors, you can manually deploy to production. So really, the difference between continuous deployment and continuous delivery is continuous deployment, there's no human involvement. Continuous delivery, there is. And you're manually deploying things out to production. And so again, this is CI/CD, and that's really all it is. Now, all of the bazillion tools that could be possibly used here, that's where things can get complicated because there are just so many tools that are involved in getting this to work. And one of those tools is Jenkins, right? And so Jenkins is what we're going to be talking about after the break. So here's what we're going to do now. So let's circle back here. Whoops. Let's circle back here. And I'm just on my local MacBook Pro here. And I don't believe I'm going to need to remote into anything back in Maryland. So this should be, we should have good response times here. So here's a directory that should look very familiar to you guys, right? And the name of my directory, I just put today's date in here. But I should say the contents of this directory should look very familiar to you guys based on what we just finished doing. And so let's take a look at the sample underscore app.py. And again, as a review, this is the Python file that is going to fire up the Flask web application framework. And in here, you can see that we're importing some things from Flask that we're going to need. We're going to need the class Flask. We're going to need the request module. We're going to need render underscore template because that's going to give us our web page. And then what do? Well, we create an object of the class Flask that will have dunder name as its value, which is simply going to be the name main. And then we've got this decorator here, right? And our decorator says, if someone tries to go to the root of the web hierarchy, which is like, localhost :8080, right? Then what are we going to do? Well, remember that this decorator is like the icing on top of the function cake, right? So there's the decorator, it's the icing on top of the function cake. And so if someone goes to the root directory, we are going to render or display whatever is in the index.html file, right? And you can see I've got this commented out here. We talked about this last week. This was sort of the first iteration of what we did. So when somebody goes to localhost : whatever the port setup is, here it's 5050. We're going to be changing that a couple times, right? So here it's 5050. And if I was to say Python 3 and then the name of the file, this is going to run, it's going to start on port 5050. And here's where it's checking to see if dunder name, and that's why up here you can see the name is going to be main. So if it's equal to main, then I'm going to say sample.run. So sample, remember, that's the name of my object, which is from the Flask class, which is a web framework object, right? This is what's allowing me to do this web stuff. And I want to run it. I'm going to run that. Think of it like you're running a web server. And we're going to do it on all ports that are up on the system, or I should say on all interfaces that are up on the system. And we're going to do it on port 5050. So let's run this. So we'll say Python 3 and sample underscore app.py. And what we should see here is, and you can see it's running it on the local host IP and port, and it's also running it. So if there was another system on my network here, right, on this wireless network that I'm on, someone could type in 192.168.1.48:5050, and they could hit it there too. So they can hit it on the local host interface. They can hit it on the actual IP address that's on my wireless card interface, right? So in either case, what we can do is I can pull my web browser up here. And where are we at? Here we are. So you can see I've got localhost colon 5050 in here. So when I hit enter, we should see the you are calling me from the local host 127.0.0.1. Now remember, I'm running this. There's no Docker involved. There's no container involved here at all. This is simply the Python application running, right? We haven't built a Docker file. We haven't created the container, none of that, right? So again, if I click refresh, it's just going to say, you're calling me from 127.0.0.1 because I'm running the application on this MacBook Pro, this laptop on which I'm showing you guys these demos tonight. Okay, so that's cool, right? And you can see here that we get this little log that shows us what's going on. That, oh yeah, they're accessing the root of the web hierarchy, right? That's what that / stands for, using HTTP 1.1, and we're getting a response code of 200, which means, hey, everything is working great. You can see that it's looking at the style.css file. And that's what's giving us that steel blue background. And that's what is, and let's take a look at that again. So if I was to say more on static style.css, you could see it is literally a single line that just says in the body of that HTML page, the background should be light steel blue. Okay, cool. Well, what about that index.html page? So let's go to templates and let's say index.html. And let me pull this up here further. Okay, so very simple HTML file, right? And it's in the head section of the file where I tell it, hey, this is how you get to that static style.css. And it's just called Python sample web app. And what are we doing? We're just returning, right? We're saying you are calling me from, and remember, this is referred to as Jinja 2. And Django is the name of another sort of web framework language that will allow me to actually call or use Python code that is dynamic in the web page, right? That's dynamic in this index.html page. And what we're saying is here, request, right? And then give me the attribute remote address. So I want the attribute of the request, which is give me the remote address that request is coming from. And that's why it's displaying the 127.0.0.1, right? Okay, so that is kind of a whirlwind tour of our app. So any questions, again, on just the Python app? And I'm hoping that this is review and that it, again, is resonating with you guys a little bit more this week, having now done this on your own. So any questions about anything you guys saw there in the application, in the Python sample_app.py file? All right, if you think of any, you can drop them into the chat or let me know. So that's our sample_app.py, okay? Super straightforward what we just did right there. We validated that everything was working like it was supposed to. And so now our next step is to create a bash script that's going to build the Docker file. And let me do this here. Let me say rf tempter. And that is probably not what I wanted to do. Okay, good. There we go. Okay. Make sure. Okay, good. All right. So we're good. All right. So now we've got this bash shell script here. So let's go ahead and take a look at sample-app.sh. Now, again, we looked at this last week and we saw that what is it doing here? All it's doing is the bash shell script is creating 3 directories. It's creating the tempdir directory, and then inside of tempdir it creates 2 additional directories. The templates directory, in which your index.html resides, and then the static directory in which your style.css file resides. Okay, great. Well, then what do we do? Well, we're going to copy our sample_app.py, right, our Python Flask web application. We copy that into tempdir. And then we do a recursive copy because it's a directory that we're copying out of called templates. And again, I think I commented on this last week. It says star, and that means everything in that directory. Well, there's only one thing in that directory. So you could put index.html there if you wanted to, but star is going to get the job done. And we're simply going to copy that into that new templates directory. And then we do a recursive copy of everything in the static directory and dump it into the temp.dir static directory. Because remember, right, if I clear the screen, remember right here, I have a static directory and a templates directory. Those are not in the temp.dir yet. That is what the build script is doing, because it's in the temp directory that it's going to create the Docker file. So let's bring this up here. And so these lines here are going to create my Docker file. And you can see all we're doing is echoing. In other words, we're pushing text into temp.dir/Docker file. So we're pushing it into the Docker file. And you can see all these commands, all of this output is being appended, right? Or initially it's being written to and then appended with the two greater than signs into our Docker file. So we put this line right here, what's in the quotes, from Python, run pip install flask, copy .static into that directory, right? Into home my app static. And then we're going to copy the templates directory into home my app templates. And then we're going to copy the sample app py into home my app. And then we're going to expose everything on port 5050. And then we're going to run the command that starts our application. Now, down here, you'll notice that we have cd into temp.dir, and then we're going to build out, we're automating all of those Docker commands that you guys had to manually run in lab 627. And hopefully you remember that you had to cd into the temp.dir, and then you had to type in docker build -t sample app dot, and then you had the docker run command. And then you could even do this docker ps, and then, I've got this, and you can add these commands in here, right? So this is going to do everything for us in a single bash script, right? So if we ran this script, if I said bash sample dash app.sh and hit enter. Now, the reason it's asking me for my password, I'll talk about here in a second, and let me get this typed in here. And I hope I did that right. And the reason it's asking me for my password is I have a command in there, which is it's called sudo. And that is a command where it's going to ask you to enter your password in, because you're proving that, yes, I am this user, and I want to do these commands. And the reason I need that is for what we're going to be doing with Jenkins, right? Well, it's not so much Jenkins, it's that it's running on an EC2 instance in Amazon Web Services, and you have to type in sudo in order to do a lot of the commands. So anyway, so there we go. I mean, take a look at that. By adding those additional lines at the bottom of the script, you can see that the web app is now running on port 5050. Well, if that's true, then I should be able to come over here and click refresh, right? Now, you'll notice what changed. The IP address, it's no longer 127.0.0.1. We built a container. So we have a Docker container that's running on this MacBook Pro, because I've got Docker installed on here. I've got Python installed on here. And this is where when Anj was asking questions about being able to do it on his Mac, yeah, if you can get Docker installed and you can get Python installed, then you can do exactly what you see me doing here. So the IP changed because that's the default range, that 172.17.00/16. That is the Docker default range to run things. So you can see that it says you're calling me from 172.17.0.1, right? Which is the Docker container. Because again, those extra commands that I had at the bottom here, let me clear things out. And let me cat out the sample-app.py, or I'm sorry, .sh. So these commands right down here, right? I CD'd into the temp dir. I used the Docker file to build my sample app. And then I kicked off my Docker container on port 5050, gave it the little nickname, right? Sample running, so that I could easily refer to it when I go to shut it down or list it out or whatever. And then I just ran this ps-a command to show me that, hey, it's actually running. And again, if I was to say Docker ps-a, oh, sorry, hold on. There's I've got a bazillion things running here. So if I said Docker ps-a and then I did a grep command here on sample running or sample run, that's why, and this gives me just what I want to see. So you can see that that this is running, right? That this is here and it's running. And so I should be able to actually see it if I said Docker ps as well, grep on sample, I should get the same thing back. And there it is, right? So my Docker container is running. And now when I'm communicating with that web app, it's inside of a Docker container running on this MacBook Pro. It's no longer that single Python script running by itself. We've wrapped all of that into a Docker container. And that's why the IP address changed. So if I wanted to stop this, I could say stop sample running. So there we go, Docker stop sample running. And we'll let this finish up here. It's going to probably take a second or two because I'm doing it on my laptop, which, as you saw, is running all kinds of other stuff. And then we could go ahead and actually remove that, right? Let's say, hey, I don't need this container out here. So I'll say Docker remove sample running. So right there, if I was to say Docker ps-a and grep on sample, we should get nothing back, right? We don't see anything come back now because we've gotten rid of it all. So that is how you could add in at the end of that script. And let me cat that out one more time, sample-app.sh. That's how you could add in the commands to automate the building of that Docker container. You're just, again, all you're doing is taking those commands that you were manually running and you're putting them here at the end of this script, because that was where you would run it. That's where you would do those manual commands after you created the file that had all of this, right? Your sample-app.sh. You then had to manually run all of this. So let's just put it in here and be done with it. And again, we want to have that in here when I go to talk about Jenkins, right? So let me we'll do a quick level set right here. The web app was up, it's running. We made modifications to it. Or I should say, yeah, we made modifications to the build script, which now auto-magically fires up and runs the application. So let me ask you, what questions do you guys have about what I just demoed there? Any questions that you can think of, or questions that you might have come up with while you were working, or any concept that might not be clear? And again, remember, right now, everything I'm doing on this little MacBook Pro, right? So what questions do you guys have? There are no questions? Nobody has any questions. All right. So hopefully everybody's good there. And so if there's no questions, whoops, sorry. If there's no questions, let's go ahead and do this. So I was running it on port, if I go into sample_app.py, I was running this on port 5050, right? So there's port 5050. So what if that's not working for me? What if I want it to be port 7070? Because for what, maybe let's say 5050 is taken. So I want to use 7070. So I'd have to change it in the Python script, but I also have a reference to that here. And you can see right there, we're exposing, right, port 5050 from the container. So I'd need to change it here. And then where else? Yeah, down here when I go to run that Docker container. Whoops. So we'll say 7070:70 7070. All right, and let's save this. So those are the only two places I would have to make that change. Now, I'm going to say rm minus rf on temp dir. So I'm just going to wipe the temp directory out again, because what am I going to do? I'm going to run my bash build script, which is going to create a new temp directory, which is going to have the new port number inside those scripts. So when the container gets built, it's no longer running on 5050, it's running on 7070. In fact, so here I am on 5050. Let me click refresh. And you can see I can't connect to the container, right? Because again, we stopped the container, which would have broken it, right? We would have seen the same thing here, but I also deleted the container, right? So it is definitely not running, which is why we get this, this unable to connect here. So let's come back over here. And now let's say, oops, sorry, not sample. Let's say bash sample-app.sh. And I'll hit enter. Oh my goodness. It should have been caching that. I was hoping it would, but it wants me to enter in my password again. So I type in my password I used to get logged into my Mac, and here we go. It's going to go out and it's going to do all of the build steps that you saw. Now there is some stuff that's cached in here, and this is running much quicker because if I say Docker images, remember, oh boy, so there's a bunch of images on here, but there's a Python image on here that when you run it the first time, it needs to pull down. But once it pulls it down, unless I delete that image, it's going to leave it there. And so then it's going to be much quicker. All right, so if I say Docker ps dash, and I should be able to say Docker ps and then grep on sample, we should see that there's our web application, right? So I changed the port in the two files in the commands that needed to have it changed. And so now it's running on port 7070. So if we come back to our web browser and I click refresh, right? 5050 is not going to work. I got to come up here and we got to change it to 7070. I hit enter, and there you go. And so we just changed the port number on which this application runs. Okay, pretty cool, right? Pretty cool. So let's do the following. Let's go ahead and say Docker stop sample running, and I misspelled running, so it's going to give me an error. Let's drop a second in there. So did I misspell something else? Docker stop sample running. There we go. Okay. So we're going to stop that container. Remember, there's a container that's running. It's not a script that's running on my Mac. It's running inside of that container. And so now it's not. Now we stopped it. And so if I stop it and I come over here, okay, it's broke. So now we're going to wipe it out. So I'll say Docker rm sample running. And now that container is gone. So let's go ahead and talk about, okay, so I'm working with a group, or maybe it's just my individual GitHub repo, and I want to make some changes and then push those changes up to my GitHub repo. Because remember, up until now, everything you've seen me doing, I'm doing locally on this MacBook Pro. So I haven't pushed anything. You haven't seen me do git add asterisk or git status or any of that stuff, right? So now let's take it to the next logical step. Okay, I want to push this up to my GitHub repo, because going back to, and let me make sure, hopefully I can remember where it was at here. Yeah, going back to this, right? So developers write the code. Okay, so I've written the code. I know that code works, and I want to commit it to the repo. Okay, so that's what we're going to do now. So how do I do that commit to the repo? So we'll say git status, and you can see that quite a few things have changed here, right? So we're going to say git add asterisk, and then if I say git status now, you can see that those changes, and let me take a step back. So what you did not see me do, which had already been done earlier, is I did a git init in this directory that I'm sitting in, right? Where I created my files, I did a git init, and then I did an initial, git add, and then a git commit, and pushed it all up into the repo, right? So you didn't see me do the git init, but assuming that we've already done that, here are these files. And so now I've added those files to my staging area, right? Which means that these things are now ready to be committed. So what I would do is I would say git commit -m, and let's put in here changed port from 5050 to 7070. So we'll do that. And there's my commit. So now it's been, again, remember, this is Git, and this is on my local system. If you're doing this on your virtual machine, everything I've been doing so far is going to work identically on the virtual machine, except you'd pull Chromium up because if you're running the app in a container or however you're doing it, it's inside that virtual machine. So that's how you would do it. So now once I've committed my changes, I want to do my push, right? Git push origin master. And there we go. And so now it's saying that it just did this push. Well, how can we confirm that? Well, let's come over to my GitHub repo. And again, this is a private GitHub repo. And you can see the last thing that happened was the port was changed from 7070 to 5050. Well, we just did the opposite, right? And you can see right here, 2 hours ago, 1 hour ago, 2 hours ago, because again, I definitely walk through this to make sure that this is going to do what we expect it to do. So if I click refresh, I should expect to see that some of these things should say now or like 1 minute ago. Yeah, here you go. So the sample app.py, and look at the comment here from the git commit. And you can see that we changed the port from 5050 to 7070. Now, the static directory hasn't changed, right? The templates directory hasn't changed. In 2 hours, it hasn't changed because the index.html and the style.css, well, those are just sitting in that directory, right? No big deal. Okay, so now I've got this pushed up here. So you decide, oh, you know what? I don't want to run this on port 7070. I'm going to run this on port 9090. So what would you need to do? Well, you would simply come back here. You would VI the sample-app.sh, search out 7070, and then change it to 9090. And there we go. And so we do it in our build script, and then we're going to do it in our sample_app.py down here where we've got 7070, and we're going to change that to 9090. And then I save that file. Well, remember, if I say git status here, yeah, hey, Git is tracking these things, and it saw that, hey, you made some changes. What do you want to do here? Well, let's just say git add asterisk. So now if I do git status, okay, great. So these went from the working area into the staging area, and now let's commit these. So git commit -m, and I would say changed port from 7070 to 9090. All right, once that's done, git push origin, origin master. And then I push those changes back up to GitHub, right? Because developer, I'm working on the code, I'm changing the port around. So we come over here, and now these said 3 minutes ago. Let's see what happens when I do this. Yeah, so this just changed, that just changed. And I didn't do the build, right? So the tempter still shows that it was changed 3 minutes ago, right? So we've got this information that's up here on our GitHub now. And so the next step, and this is what we're going to talk about after the break, is, okay, well, it's great that, we've got this. How could I maybe automate this to build this at the click of a button? And again, using what is in my GitHub repo. Because remember, if you think about it, if you and your teams are working, you got 5 people on your team, and you guys are all pushing up to a repo in GitHub, you want a way, you can test your portion of the code, or you could pull all the code down, but wouldn't it be great if you could do that to test the build at the click of a button? And that's what's going to happen. Oh, yeah, no, Christy, no worries. So Christy wants to know, can you explain the purpose of the tempdir? So tempdir is not a file. Remember, tempdir is a directory, and it's in this temporary directory that we create the Docker file that's going to build our container. And so all we're doing, and maybe we come back and take a look at this view here and make it a little more clear. So here is think of this as my main project directory. So I've got my main bash script that can build my Docker container in the Docker file. I've got my main Python script here. And then I've got my static directory, which has got the style.css, and the templates directory, which has got the index.html. And so think of these as like the master copy, the gold copy of your project. Now, that tempdir, if I say rm-rf tempdir, I'm just removing tempdir here, right? Because remember, that directory doesn't exist unless I run the build script. And so all we're doing is creating a temporary folder, if you will, directory, into which we're placing our sample app.sh file, right? Our sample underscore app.py file, and our static and our templates directory. And we do that, again, when I run this command, bash sample dash app.sh. Oh boy, oh boy. And then when you run that script, right, it's going to build, it's going to create the temp directory, it's going to put everything in there. And then again, at the end of my sample-app.sh, I added in those 4 commands to do this, what you see right here, which is cd into the tempdir and then build the container for me. And so it's building that container. And so now when I say, let me clear this out here. Now when I say ls, see, tempdir is there. If I list out the contents of tempdir, it's a mirror image of what I have in my current working directory, with the exception of there's a Docker file in there. And that Docker file allows me to build that Docker container. And so then these are just copies of the sample underscore app.py, static, and templates, because we need that for the Flask web app. So all it's doing is copying this file and those 2 directories from here, where I'm at right here. It's copying those 3 things, and it's creating a Docker file. And then what I did at the very end, remember, this is different. This is adding in here a little bit. What I did at the very end was I said, I don't want to have to type all that junk in every single time I want to build a container. So I just put it at the end of my script. So when I run that script, it creates that container, runs it on that port 9090, and then it greps, it shows me, hey, it's actually running. And so the tempdir is what that Docker file is using. And you can see here, if I come back and I say 9090, we're up and running, right? So Christy, does that answer your question? So the tempdir contains a copy of 3 things that we have in like that main directory, which is the Python Flask web app, and then the static and templates directory. And then we create that Docker file with these commands here, all of those echo commands. And then we cd into that directory. Our script is doing this. The script cds into that tempdir directory and builds our Docker container using that Docker file. Yeah. And so again, once you build this, right, once you have the tempdir and this thing is up and running, you can remove that. You can just say rm-rf tempdir and it's gone, right? Because it did what it was supposed to do. It created the container. The container is its own mutually exclusive little hermetically sealed bubble that is running our Python Flask web app right now. All right, so let me do this here. We'll say Docker stop sample running. And then we're going to remove it. We'll say, come on, MacBook Pro. And then we'll say Docker RM sample running. Because again, we don't need that container anymore because we're changing things. You don't have to remove the container. You can leave it there, right? Just you'd have to remember that it's running on port 9090. So maybe when you name it, instead of the command that we ran, see if I can find it here. I think I've got it in here somewhere. yeah, the command we ran here, and again, that command is running it on port 5555, but that command where you do the dash dash name, if you wanted to create a whole bunch of sample running sample apps, you could say the name is sample running 9090 or sample running 5555 or sample, in other words, I'm just putting the port number that it's running on in the name, the alias that we're using for it to make it easier to identify, right? Okay, so now that we've done that, let's do Control C here. Let me, I think we're using port 9090. So if I say get status, right, GitHub's like, hey, or I'm sorry, Git is like, hey, you've got these things here that, what do you want to do? Well, let me go ahead and let's, yeah, I'll go ahead and build the app one more time here. Let's do, where's my bash script at? There we go. So if I run the bash script, right, and this is going to have me, okay, good. See, it cached my password there, right? I didn't have to enter the password in there. Okay, so good. So it goes through, it creates it creates the temp directory, copies those three things it needs, the Python Flask web app and the two HTML style CSS directories, and then it creates the Docker file. And then it builds the Docker container and it's running it. So now in the main directory here, there's that temp directory. So let's go ahead and say get status. And you can see, hey, you got some modified stuff here. Okay, get add asterisk, get status, everything should be green. And then we'll say get commit -m and changed port to 9090. I don't remember what it was before, but we'll say change port to 9090. I'll say get push origin master. And there we go. So all of that work just got pushed up to my GitHub. So you can see 10 minutes, 3 minutes, or sorry, 10 minutes, 10 minutes, 3 hours, 3 hours. If I do a refresh here, we should see some now. And there you go. So the sample app changed, the Docker file changed. Oh, I'm actually down in tempter. Sorry, let me pop up one level here. So even back at the main section here, you can see the tempter change. And this is reflecting, this isn't reflecting when I pushed it. That's reflecting how long ago I made the change to those files, right? So Git is tracking like how long ago those changes were made. So if I click refresh, it's going to say 9 minutes because I made the changes and then we kind of talked about what we were changing. But the temp dir, right, that was literally just done. All right, so we are going to take a 10-minute bio snack break here, and let me clean some stuff up here. Sample running. So we can stop sample running now. And what we're going to do is we're going to pick up after break. We're now going to take that next step. And the next step in the CI/CD pipeline is, and hold on here, I'm sorry, I'm thinking and talking and that's not working. Okay, so the next step in the CI/CD pipeline for us is we've got this developers writing code, right? And you and your team are doing your code and you're committing the code to the GitHub repo. So now we're going to talk about, well, how can I maybe automate the building of that code so that I can click a button and boom, it auto-magically there's a job that just runs and builds my code and tells me whether or not the code was successful or not. So that's where Jenkins comes in. And then if that works, we could have some testing that Jenkins could even do, where we could have Jenkins send a request to the Python Flask web app looking for, did it say you are calling me from, 172, whatever, or whatever it's calling you from, to have that test, right? So we're gonna complete the continuous integration here this evening after we come back, and we'll come back at 5. What do we got? 8. So it's 8 o'clock. 8:20. Sound good? Any questions before we bust out on break? All right, let me pause our recording here. All right, so we are back from our break, and we are now going to take the next step. In fact, give me just 1 second here. Okay, sorry about that. All right, so we are back, and here's what we're going to do now. We're going to talk about this automatically build the code, or at least, automate the building of the code. And how can we do that? Well, it's this dude right here, Jenkins. Now, Jenkins is a software application that you can install. It's free. And you'll notice if you were to look at the lab on Jenkins, which is 636, you can see it. It explains how you would install it on, you actually create a container to run Jenkins inside of. So this IP address right here, this 35.173.47.246, you might want to make a note of that because we're going to have a little test here in a second. So 35.173.47.246, that is the IP address of my web server, or I shouldn't say my web server, one of the servers I have in Amazon Web Services, right? So this is out in Amazon Web Services land. So once you have Jenkins installed, let's go ahead and get logged in. So I'll log in as the admin user. Whoops, I think it knows my password there. Or it does not. Okay. So we'll type it in here. That should be the password. All right, there we go. Okay, so you can see that I've got some build jobs in here, right? So here's what we're going to do. We're going to build a Jenkins job that will build our Python web application for us, right? And all I would have to do is click a button. It's going to go out to my GitHub repository. It's going to pull all of that code down, create that container, and run that container for me right here on this Ubuntu Amazon instance. So how do we do that? Well, I'm going to come up here and click on New Item, and we're going to call this Build Job 004, right? Now, you'll notice down here that we have a lot of stuff we can pick from, right? Now, they're going to start us out with some freestyle stuff. The SCM is Software Configuration Management, and that is our GitHub, right? That's what we're using for our software configuration management tool, is we're using GitHub. So let's click on Freestyle Project, right? And we'll click OK. And this is how easy it is to configure Jenkins to run this test. And so I'll just call, you can put a description in here like, hey, I'm creating this, and I'm doing this addition to my web app, whatever. I'll just put 004 in there for us. And our source code management, right, is Git, which is going to be tied into our GitHub repository. So what was that URL? Well, it's github.com/your username / the name of the repo, which is AACC-sample-app.get. And don't forget to put that .get at the end, or else it won't work. Now, the first time you use Jenkins, you would have to have generated that personal access token. Or I'm sorry, let me take a step back. So the first time you use Jenkins, you'll notice that it says credentials none. You would have to add a credential in. And that credential would be the personal access token from GitHub. Now, I've already got that in here, and you can see as soon as I click on that, it gives you the error in the background, right? It tells you, hey, password authentication removed, blah, blah, blah. Well, that's okay, because right here, I created, when I did the add earlier, I created my little personal access token, pasted it in, and the error goes away, right? So this is going to authenticate me to my GitHub repo, or to GitHub for access to my repo. And we're going to come a little bit further down here. And remember, we had something that we wanted to do, which is execute a shell script. Well, what was the name of the shell script that we were executing? It's sample-app.sh. And so I'm going to click on Save. So what have I just done there? In 3 steps, right? Created the new build app job, gave it my GitHub repo, told it I'm using Git as my local source control, software control management, and gave it my GitHub personal access token, and then told it, hey, when you pull that code down, run that bash shell script. And those three things, that was exactly what we were doing over here, right? So I'd run the bash shell script here, and it would create that temp dir, and it would fire up that Docker container. And so all I've done is using Jenkins, I've created the job. If I go back to my dashboard here, you can see here are all my jobs, right? So app job 1, 2, 3, and 4. Well, 4 is the one we just created. So if I click on that, right, it takes me back here, and we were just here a second ago, and there's a little comment I put in. All I have to do is click on build now. So when I click build now, it's going to be right here in the lower left. You're going to see number 1, right? It might be a little bit small. Let me see if I can. There we go. Make it a little bit larger for you guys here. There we go. So build app 1, right? So let's click on that. It was successful. We got the green check. If it's not successful, you're going to get a red X, a red circle with a red X inside of it. So you can see that the build was successful. Well, let's go ahead and let's take a look at our console output, right? I want to see, what did it do? Well, here you go. It built the workspace, right? Use credentials in order to go to the remote Git repository, which is GitHub, and there's the repo right there. And as we go down here a little bit further, you can see that the temp dir was already there, so that's not a big problem, because what's going to happen is, here are all of those steps that we've already seen, right? Run pip flask. This is the Docker file right here, right? It's building the container for us right here. And then the most important thing is at the very end, where it says finish success. And you can see that it's running our application on our Amazon EC2 server. So this is where we take a step back to, where are we at here? Yeah, oh, sorry, it's right up here. We take a step back to this IP address. So here's what you guys are going to do now. You're going to pull up this IP address, and instead of 8080, and I'll drop this into the chat, you are going to type in 9090. And if you go to that URL right now, like if I come over here and I change this from 5050 to 9090, it's going to tell me the IP address of my service provider, because I'm, in a house, right? And we've got what's Spectrum Internet out here in Nevada. So now it no longer shows you the 172, right? Because we're not messing with the container locally on our system. We now have this is running on the internet. Anybody that is either watching this or would go to that IP address and that port number, they're going to hit this page. And so go ahead and let's see, you guys paste in, or can you guys actually paste anything in here? I wonder if you guys can paste. Yeah, I don't think you guys are able to paste anything in there. Let me see here real quick. Yeah, so let me ask you guys, what are you seeing? What does it show you? Because what it's going to show you, and go ahead and put it in the chat, what it shows you is it should show you the IP address of Comcast or Verizon, which is probably what you guys have. Yeah, so Christy sees 173.69, 195.201. What about you, Dylan? What do you see? And Nathan, if you're still on your phone, you could still click. If you pull the chat up, you could probably click on it. It'll show you whatever your IP address is that the cellular carrier has given you. So what do you two guys see? And I'll give you a second to type that in. Excuse me. Dylan, Nathan, you still with us? All right, it looks like we may have lost Dylan and Nathan. All right, Dylan's here. All right, Dylan, so if you go to that URL, or you go to that IP address :9090, what does it show you? Says you're calling me from what? And Nathan, are you still there? I think we lost Nathan. All right. So Dylan gives us a 107, 107, 56, 235. So let me ask you guys, Christy, Nathan. I'm sorry, Nathan typed that in there. So Dylan, we're waiting on your input. But let me ask you guys, is your internet service provider Verizon or Comcast? 71 is definitely Verizon. Dylan, Dylan, you got to be Verizon. Because my Maryland IP is 71 something 5960 or something like that. So that's definitely Verizon. All right, good. Okay. So we've now got this running up here in Amazon Web Services on this EC2 instance. And that is how you can use Jenkins to automate the build and the testing, right? And you could see how easy and how simple it is to do that. So let's force what I think is probably going to be an error here. Let's create a problem here. So if I go to my Jenkins dashboard, let's say I want to create a new item, right? I click on create new item, and I'm going to call this build app 005. And it's a freestyle project. We're going to click OK. And we'll type in just as a comment 005. We'll come down to get for source code management. I'll type in my repository, https://github.com, bonfigli/AACC-sample-app.get. You see we're going to get an error, right? Because I haven't told it, yep, there's my personal access token. And then we'll slide down here a little bit further to build steps. We'll click add a build step, which is execute a shell script, and we'll say bash sample-app.sh. And I'll click save. Now, when I go to run this, right, when I go to build this, remember the other app or the other job, which started the app up on port 9090, is still running, and we have not changed the port on this build app job 005. So if I was to tell my coworker, yeah, go ahead and run it, let's go ahead and click build now, and let's see what we get over here. All right, so it shows that it was able to build it. However, I would think, excuse me, that we should see down here that maybe, oh, it shows success. Okay, so it shows it's successful, should still be running. That's what oh, sorry, localhost. Yeah, I thought we were going to see an error there because it's already running on port 9090. So it looks like Jenkins went ahead and built it and said it's running on port 9090. So how can we check that? Well, to check that, to check it, I would actually have to remote in. So I'll leave the checking portion out for right now. So, because I can get onto that EC2 instance and then make some changes. So here's what we're going to do, though. Here's what we're going to do. So now, if we go back to this image, right, I'm hoping that this is driving home. Okay, we wrote the code, we tested the code locally, we committed it to our GitHub repo, and now I can click a button using Jenkins to auto-magically build that code. And that is pretty cool. That is pretty cool. And so there's no errors, right? We're not seeing any errors. So here's what I'm going to do. We're going to create a new job in Jenkins, right? So, but here's what we're going to do in Jenkins now. So now we're going to take care of testing, right? Because we see what IP address I'm coming from here, right? In fact, let me copy this right here because that's going to be the same thing. So now that I've got Jenkins set up to build my application, I can set Jenkins up to test the application as well. Well, how do we do that? Well, let's click on new item. We're going to enter the name here, and this is going to be called, we'll call it test app job dash 001. So this will be our first tab. Well, actually, let me do this. We'll do 006. We'll do the next one in the, what am I trying to say? The next one in the sequence there. So we're going to do another, it's a freestyle project again. And so then we'll go ahead and click OK, right? All right, so now we've got some different choices to think about here. We're going to add a description in here. I'll just call this, test job or test app job -006. So now what about these options? So we're going to leave source code management. We're leaving that set to none because this Jenkins job is not about pulling down and building the code. It's about testing the application that we just deployed, right? So we're interested in the build triggers, right? These build triggers here. And so we're looking for build after the other. Yeah, so we're going to pick this one right here. Build after other projects are built, right? And if I was to hover over this here, you can see it just says build after other projects. It's not much help at all, right? So we've got this projects to watch. So I'm going to go ahead and say that we're going to watch build app job, and we'll say, we don't have 006 in here, but we're going to create 006 because we're going to walk through a whole setup here. So I'll say build app job 006, even though that's not there yet. And we'll go ahead and say, I think that's it. Trigger only, yeah, so trigger only if the build is stable. So only if the build is successful am I going to trigger this test that we're getting ready to do. So we're going to come down a little bit further here to the build tab or build steps. And we are going to execute a shell, right? So here's what we're going to do. We're going to type in a real quick command here. We're going to say if curl, remember that curl command that we ran, that we could check to see if we're going to get back a status code of 200 or not. So here's the thing. Remember, in the lab, it's going to show you that 172.17 because you're doing it in the virtual machine, in a container, in the virtual machine. But here, we're not, right? Here, I'm using, and let me actually go ahead and paste it in. So here we're using this box out on the internet. So I'm trying to get here, colon, and for this one, I'm going to change it. We're going to walk through everything. So I'm going to say 7070 / pipe to grep, and we want that in there. You are calling me from that IP address. If that's the case, then exit 0 in the status. Remember, exit 0 with a shell script means success. Whoops, I'm going to back all the way up here. Otherwise, right? So if this curl command works, where we go to that IP address and that port number, and it says, hey, you're calling me from that IP address, which is what we're seeing when we run the application, it's going to exit with a status of 0, and then Jenkins knows, hey, it worked. If it didn't match that, if it doesn't grep that, then we've got issues. We're exiting with a status of 1, and that's our script. So we're going to click save, right? Now, here's what we're going to do. Remember, we haven't created build app job 006 yet. So we're going to change some things here. So watch what we do here. Let's walk through the entire thing one last time. So let's say your boss comes to you and says, you know what? Running on port 9090 is not working for me. So let me pull this back up here real quick. So developers, write your code, commit it to the GitHub repo. We're going to create a job to build the code, to build our container. And then we've got that automated test that should run if it is stable. So here I am, I'm the coder. What do we got going on this directory? I'm going to say rm-rf temp dir, right? Because I'm going to create a whole new Docker file with new values in it. So we don't want that temp dir there. Let's go ahead and say vi sample -app.sh. I'm going to find 9090, and I'm going to change it to 7070. There we go. So we're changing it to 7070 inside of the bash shell script. And we also have to do that. Remember, when we start up the application with the Python file, we have a port number in here. Oops, I should probably just move my way down there. And we're going to change that to 77. All right. So now with those two things all set up, remember, I'm the local coder. I'm at my house or I'm at my desk, and let me check and make sure, does this actually do what I think it's going to do? So we'll say bash sample dash app.sh. Oh boy. We'll put our password in because I've got the sudo command in there. And there we go. And it's now going to run off. It's going to build this because, again, I want to make sure, hey, does this work? Before I push my code up to the GitHub repo, is this going to work? All right, well, it says it's running. Let's check locally, right? Remember, we're local here now because I'm testing at my house or at my cubicle or doing whatever on the test server. Okay, I know it's working. I know the container's working great because I'm getting that you're calling me from 172.17.0.1. That is a Docker default IP range there. So now that I know that that's working, let me come back over here. So I'm the developer. I've written my code. I just tested my code. Let me do a quick git status. Okay, I got some modified stuff here. Well, let's get this pushed up to my GitHub repo. So I'm going to say, what am I doing? Git add asterisk, and then git commit -m. And we're going to say changed web port to 7070 from 9090. So there's my comment to the commit, and then it's git push origin master. And off it goes. So now I'm going to check, hey, okay, did the GitHub repo update? Let me come over to my GitHub repo here. Let's see what we got going on. The sample app and the sample app sh and py should both show now or within a minute. And there we go. And the temp dir was also just created. So, okay, cool. So my GitHub is all set up. Let me come over to Jenkins. So now we're going to create the build job in Jenkins, right? That 006 I was talking about. So let's call it build app. Oops, sorry, I'll say 006. We'll call it a freestyle project. We'll click here on OK. I'll put in 006, float down to Git. Remember, this is a build job, right? So we're going to use Git as our source control, and then it's going to be github.com/my username /AACC-sample app.get. Credentials, right? There's that big error, right? Because it's like, well, wait a minute, you don't have access, but then you've added your credentials. Boom, we're in. Let's float down here to the build steps, and we are going to execute a shell, and we are going to say bash sample-app.sh, and I'm going to click on save. All right. So that is really the CI process right there. Okay. Now, again, we've got the build to do here, and we've got the testing to do, but that is, in a nutshell, we wrote the code, we tested the code locally, we pushed the code to the repo. I've got the Jenkins job now. Let's run the build and see if it's going to run this on port 7070 for us. So I'm going to click on build now. Right down here, we should see a little icon, or I'm sorry, a little indicator as to what's going on. We've got the green check. So if I click on that and we look at the console output, let's see what we got going on over here. Everything looks good. Yeah, look at that. Boy, built that container. Success. All right. So if that's true, I should be able to come here and go to 7070 and hit enter. And I think it's because it's running it on, I think I may have had something else on 7070. And this is what I thought would happen with 9090. So I am going to have to dive in here. Give me a second. Maybe I should have went back to port 5050. So let me remote onto that EC2 server. And let's make sure that we don't have anything running there. And then I'm probably going to have to do a password here. Sure enough. All right, so here, well, we got disconnected, but here, all right, so here we are. So this is the server in Amazon, out in the Amazon cloud, that is running the Jenkins application. It's also running the Docker container. So if I was to say Docker ps-a, let's see if we already, oops, sorry. And so here's where sudo docker, and I hate this, docker ps-a. I should fix this, but I just leave it the way it is. All right, so it shows 9090, and it's given us an issue with 7070. So Docker ps-a. Oh, ah. Oh, I keep forgetting the sudo command. Sorry about that. So I'm thinking here as to why sudo docker images. Oh, it's because I was trying to use the same Docker name. So hold on, let's do this. So I'm going to say sudo docker stop sample running. I apologize. So I gave the containers the exact same names, and that is why we're not running. And so I'm going to stop the container here, and I'm going to remove it. I'm going to say docker sudo docker rm sample running, and we'll get rid of it like that. Okay, good. All right. So now that that is gone, cd/var, where was that? Let me check one more thing here. It's in lib, should be Jenkins, and it should be jobs, I think. Yeah, there we go. Yeah, okay. So let's go ahead, let's go back to Jenkins. And now that I've got that sorted out there, and it's interesting, right? Because Jenkins said, and Jenkins was correct, right? It did successfully do the build. It's just that it couldn't run the container because the container was using the same name and the same container name as something else. All right, so we're back over here, and let's come back down to test app job 006. All right, so hopefully now when and actually, I'm sorry, it did give us the red X right there. So it did fail. Now, don't fret yet, right? Because it shows us like, yeah, it failed last time, but we should be seeing a green check here in short order. And there it goes. And we'll give it a second here. Sometimes it takes it a little while. Come on, Jenkins. And again, you got the little monitor here. Boy, this is taking a lot longer than it should, but this is what you get in the free tier in Amazon. So, boy, oh boy, this is running really slow. I apologize here. In fact, let me go back to the dashboard here. And you can see that the build app job and now the test app job is running. Because again, remember, we associated the test app job with the build of 006. So whenever I build 006, the test should run. And the test that it's running is it's trying to go to the web app and confirm it's working. And boy, this is really running slow. I apologize here. And you can see we got the weather, we got the bad weather day, build stability. All right, so it looks like it went idle. Let me refresh here. All right, so it looks like our test failed. So let's see why our test failed here. And actually, let's check and see. Is it running on 7070 now? Aha. So it's not running on 7070. Let me see what we got going on here. Interesting. So it didn't start it on 7070, which means the build job. Let's go back and take a look at the build. Oops, sorry. Take a look at the build job here. So that's why the test failed, is because obviously if the build of the app failed, and that was 7 minutes, so that was not when I started it. All right, so let's do this here. Let's say build now. Let's go to the dashboard. We should see, yeah, so 5.3 seconds ago. Okay, so the build was done. Let's, not there. Let's come over here and let's make sure, is it running? Okay, so we are up on port 7070. So we are back. And let's see what the test returns here. If I was to come over here to 7070 now, there we go. So 75, 141, 199.37. All right, boy, the test is dragging here. So hopefully our test is correct. I don't have any typos in the shell script that I created there. Hopefully that's good. Boy, these test jobs are taking a lot longer than I anticipated. All right. So in fact, if you guys were to go to 35.173.47.246:7070, it should still show you the IP address that you're coming from. And now we're just waiting for our test job to wrap up here. And the test should be successful, but we're about to find out. And then this is going to be a good stopping point for tonight. And let's see here. Boy, that test job, to just do that one simple command has taken a really long time and not giving me any confidence here that we're going to get away from the thunder showers and the failed. But we'll see. All right, almost there. Boy, it took 2 minutes for that test. That's a very long time to run a 4-line shell script. All right, let me go back to the dashboard here. Let's refresh. And so it looks like our test job is still bombing out on us. So we could take a look at that, and we could take a look at the console here. And let's see. So the curl, oh, you know why it failed? Oh, no, wait a minute. That's the same IP address, correct? 75, 141, 199.37:7070. That is correct. Failed to connect. All right, so here is our problem. It looks like the connection is timing out when the curl command is trying to access it. All right, well, I'll have to figure out why the curl command crashed out. But to go back here and to kind of recap for tonight, right? Developers write the code. We commit it to the GitHub repo. Jenkins is one tool that you can use. in order to click a button and, as you saw, automatically build the code, build the container, run the application, and then we could run automated tests, right? So what do we get? We got errors. All right, well, if there's errors, failed test, right back to the developers. You got to figure out, why is it timing out? Why is the curl command timing out? All right, guys. Well, that is all I have for this evening. Does this make more sense now? Seeing the process, at least the CI portion of the process, the continuous integration piece. Does this kind of resonate a little bit more with what you're seeing in the readings and the lab and the web app? And okay, excellent. All right. Well, if you guys do not have any additional questions, that is all I have for this evening. And I will see you guys next week on Tuesday, April 11th. Have a great night. And if you have any questions, just you can hit me in WebEx Teams or fire me an email. I'll talk with you guys soon.